two, one, zero. Ignition.
Have you ever dreamt of touching the stars in the sky? Have you ever dreamt of leaving your earthly horizons and exploring the universe in its entirety? Well, this video is for you, presenting to you space travel, viable or not.
Good morning, my name is Karthika Bangaru, and today, as indicated by the thumbnail, I'm going to be evaluating whether space travel is really viable or not. So by 2021, this is actually an exciting space year because I'm pretty sure you've heard of many big names: SpaceX, Virgin Galactic, Blue Origin, etc. etc. And I'm also pretty sure that you heard of certain Mars colonization missions, the Venus expedition missions, and also some random chatter and gibberish from NASA and ISRO or any space agency on that matter of fact. So for so long, space travel has been the stuff of dreams. Even NASA and ISRO a few decades ago believed that it would take a lifetime, more like 20 years, to achieve the technology we had till now. And in my book, that's a pretty big achievement, considering the fact that we're literal apes with smartphones. Without overestimating our technology, we've come a long way because our technology has grown thousandfold than what it was in the past. Because believe me, in the 1960s or so, internet was a joke. It was a literal joke. I had no idea why it was so slow, but we were basically primitive people. So, internet then had a record speed of 15 Mbps, megabytes per second. I didn't need to tell you that. But today it's 9,000 Mbps, more than 10,000 times of what it's really capable of. And that shows you.
Oh shit, here we go again.
This shows you the extent of how far humanity has actually come in. I don't know math.
What did he say?
2 hours later.
Aha, I got it. 61 years. Speaking of space travel, what is space travel? Help!
No.
Well, for all of you clueless people, it's traversing space. Okay, to be more specific, traversing space is either for mining resources, immigrating, or occupying another planet, or obtaining information about a celestial body. Technically, it has a variety of reasons, but according to the European Space Agency, NASA, ISRO, and all the episodes of Star Trek, those are the universal reasons of space travel. Okay, thought experiment. So let's imagine a random Chad or Karen walking to me right now. You're talking to me. Oh, clearly a wait, you don't look like a random Chad. Is it me or does he not look like a Chad? Wait, why do we need space travel, bro? Why can't we just stay here and be respectful of space poop and aliens, bro? Well, for all of you lovely people who think that way, this is the reason why. Well, apart from the 5 benefits that were shown here, there are plenty more. Benefits can be either class
2 hours later.
across society, educational organizations, the media and communication industry. You know what? Just see the table. Should be better, am I right? Okay, that should conclude the lengthy list of benefits. Now let's talk about the disadvantages too. Space travel implies significant air pollution. I can't breathe. Particle pollution can be a problem. Isn't it the same thing? Space exploration is quite costly. You think? Space exploration implies high levels of waste. Many missions may not yield any results. Space exploration is time consuming. Space exploration can be dangerous. No words right now. I really have no words. Mental problems for astronauts. Okay, I'm not surprised. Problems with radiation. I'm also not surprised. Space exploration may lead to a decisive advantage of few countries, may not be line in with religious values. Extraterrestrial life forms may wipe out humanity. Okay, so apart from the last three disadvantages, we're good. Okay, you get the idea. Each and everything has its ups and downs, including extremely rational and groundbreaking theories proposed by genius engineers and scientists. But as said, there are equivalent downsides to each and everything, to each hobby, activity, and multi-billion dollar projects that may determine the fate of humanity itself. It does feel a little bit sketchy when you think about it. In the early days of exploration, we were still new to everything. It took nearly 4 centuries for Newton's laws of motions and his notion about gravity to be properly applied in real life, so that we came to the stage we have right now. Without gravity and Newton's laws of motion, we wouldn't be having all of these. The famous cartographer Ferdinand Magellan had spent laborious days. In his time, he mapped out the entire world. Although not to such an accurate extent like we have today, he spent years mapping out the world, and in the end, he had lost his life in a tragic pirate fight. Oh shit, it feels sad now. Cut the camera. Believe me, space travel has its perks, but it has its equivalent downsides too. But since we're in the primitive phase of exploring space, there's not much to be done except increase the frequency and increase our scientific knowledge and tactical knowledge so that in future missions we can do it much better than what we did in our previous attempts at exploring space. Technically, we're not exploring space, we're scouting space, because in our cosmic neighborhood, we're literally 1/64th of its area, and 1/64th of such a big area, which is said to be around 13 million kilometers. I can't imagine what 1 kilometer is. 13 kilometers seems to be out of my brain. We're technically mapping out the universe so that it's easier for our descendants, their descendants, and their descendants, basically our descendants, to map out the universe and complete the lifelong mission of space agencies. But the universe ain't that big. It's Earth, the Sun, and the other planets. Stop being planet-phobic, bro. Ignore him. But anyways, what do we know about size comparisons? Just lay down a quick comparison. Imagine you're a person standing next to a 40-meter building. How short are you going to be? You're literally going to be an ant size, because most humans are around a meter, but definitely below 2 meters, but around a meter. Now let's talk about the Earth. It's humongous, isn't it? Because we're literally a grain of sand in a 69-acre beach. Weird number, but I'm gonna allow it. Okay, my dear Chad, just to lay down some context.
The universe is extremely big, and I want you to watch the following video so that you understand how big the universe actually is.
Yet space is a whole new frontier. These are the moons of other planets, vast areas of unexplored regions, climate, and landscape awaits. As we zoom out from moons to planets, we ask ourselves, where are we? That's here. That's Earth. On it, everyone you ever know, every religion, every ideology, every conflict, every experience, every saint and sinner in history of our species live out their lives in a speck of dust, suspended in space. The sun, a ball of superheated gas, can fit 1 million Earth inside of it, yet our sun is tiny compared to the really big stars out there. Polaris, over 10,000 times bigger than our sun. Pistol Star, 3,000 times larger than Polaris. If it was our sun, it would have reached far out as Mars. And then there's this monster, UY Scuti, the largest star ever discovered, 1 billion times bigger than our sun. The extent of our solar system. Yet, it's just one of the many solar systems in our galaxy, one of them being the TRAPPIST-1 star system, believed to house 7 planets with life. Passing by Sedna orbit, witness the largest black hole and abyss among this interstellar.
Imagine a human body and imagine the supernatural black hole is the human body. Where do you think we come in? Atoms? No, we'd be way lower than that. We'd probably come into the substances and the particles that would form electrons, neutrons, and protons. Yes, quarks, photons, etc. etc. We're that small, you know? Small. Shit, wait! Are extreme conditions, and technology is built for traversing that extreme conditions. But we're talking about space here. It's an entire new dimension, okay? You can't survive under a normal spacecraft. You need a specialized spacecraft for depending on the kind of missions you want to undertake. But let's start the extreme conditions. Okay, now let's move on to the procedures of space travel. Yet another complex ass topic.
Stop it. Get some help.
Which I won't go in depth in, but I will give you insightful information to begin with. Okay, by mapping out our environment, I meant mapping out our space neighborhood. Our solar system belongs to our vast neighborhood, which is the Oort cloud. But for laying down context, I'm only going to refer to the solar system. So whenever I say neighborhood, I mean solar system. If we understand our environment to such a significant extent, we can understand what's really happening in our outer solar systems, the asteroid belt, and the entirety of our galaxy too. So using our mission on objectives based on existing information and theoretical mathematics and physics and a very complicated subject of rocket science. For some reason. It's complicated, okay? It's very complicated. Yeah, it's because they use complicated rockets. Dumb. Moving on, it includes the study of radio frequencies, knowledge of planetary orbits, using centripetal force and using acceleration in any planet's elliptical orbit, you attain greater velocity than anything you have ever met. The fastest example of such a maneuver.
My boys got those wheels filled out correctly.
Three, two, one.
Change of locations, actually. I'm recording from here because my life is shitty enough, but whatever. So as I said, these are usually the plans that is required for rational action plan for each and every kind of space mission. It doesn't matter for any kind of specific objectives, there needs to be a clear outline of every kind of variable so that there is a clear rational plan and there is some kind of probability that the astronauts won't die or the mission is a failure or there'll be a loss in billions of dollars. So go check out the link in the description because I used it as a source for my research and it helped a lot. And maybe you'll do something better in understanding everything because I'm just providing a basic summary of everything that is part of space travel procedures. A spacecraft is created with constraints for budget, design specifications and modifications, resource contention, tracking capabilities, spacecraft ascension from orbit, meaning how you leave orbit, and most importantly, data return. There are 8 types of spacecraft. The first one being a flyby spacecraft, meant for getting information like reconnaissance, and it's like the Voyager 1 and 2, which is currently surveying the outer parts of our solar neighborhood. And the second one is the orbiter spacecraft. It's meant for orbiting the planet. The third one is the atmospheric spacecraft, meant to get information about hostile environments that humans have no chance of thriving in, such as gassy planets and planets with literally no atmosphere. This fourth one is a lander spacecraft, meant for landing on an extraterrestrial object or planet. It's basically for extraction and leaving the planet. And the fifth one, am I reading this right? A penetrator spacecraft. Sounds a bit weird, but It's meant for getting information by penetrating a celestial body and transmitting data back to space agencies. It might be based on how much resources or how many precious metals and how many unknown elements are there in the celestial object. It might be to convey a geomorphological or geological patterns, etc. etc. And the sixth one, it's in the name, a rover spacecraft, like the Discovery and the Perseverance rovers on Mars. And the seventh one is the observatory spacecraft, giant space telescopes meant for looking at the cosmos with greater clarity and greater vision than anything that has ever been produced. Since it is in space, it has a narrower and a more specific view so that it can capture the beauty of the cosmos. The eighth one is the communication and navigation spacecraft. It's meant for acting as a medium between transmitters and receivers on different parts of the globe for telecommunication purposes. And there you go, that's the 8 types of spacecrafts.